Poundland's spooky light projector. I just picked this up and I thought I'd give it a go, and it's interesting. It says spooky light projector projects images onto your wall. In reality, every single one had the picture of the skull, and I brought it home thinking, is it going to have multiple images? No, it's just got one. It's the skull. So that's what you get, a skull. Let's undo this flex and try this out. I have already plugged it in. I can tell you, it's not super bright. The intensity is actually just a little bit disappointing. I was so disappointed. I wondered, well, this is a little, this looks like the standard Jutai Christmas light and power supply. Let's see if I can untangle this. But in reality, it's a little 3-volt one. It's not made by Jutai. It's made by a company called Zongshan MLS Electronics Limited, but it's in the same style. Common sort of style for Christmas lighting products. This flex is just not really conveniently. There we go. Here we are. I shall plug this in and then we shall scrutinise the effect. I'm going to take the exposure off here so that the camera can actually see things. So let's turn the light off and turn the exposure off. Yeah, so it's actually not too bad. I mean, it does project a nice sharp image, and when I point this at the wall adjacent to me, it does. I mean, it projects a useful image, although not very bright. I'm just going to turn the light back on. I'll pause briefly so you don't get swamped out here. And we're back. Sadly, this is all glued shut. It's not got screws. That's a shame. So it does come with an instruction manual. It did come with an instruction manual. There's the instruction manual, which is clearly a widespread scatter manual for all manner of things. It does say LED colour green, 220, 240, 50, 60 hertz. Usage area is 20 to 40 square metre. I rather think not, it's not that bright. And then it comes with this generic warning. This product contains chemicals including lead, known to the state of California to cause cancer and birth defects and other reproductive harm. Wash hands after handling. So if you handle it, if you're in California, you have to wash your hands after handling this. It says potential light hazards exist. This product, read these instructions. Kerf 8P7, I'm not sure what happened there, which includes below warnings, and instructions for use and assembly. It's got little hints. It's not been proofread. And it has a couple of warnings here. Avoid direct eye contact projector light. Never intentionally expose your eyes or others directly to the light, which sounds, that would be good for a typical, high intensity projector. And then it says this product can potentially cause instant eye injury or blindness if projector light directly strikers the eyes. That's for a laser. That's not for this. It's a generic manual. So let's get into this. And this is where I don't think the spudger is going to have much effect here, because I get the feeling it's probably been glued or ultrasonically welded shut, and the only way I'm going to get this open is to give it a little squeeze in the vise of knowledge. So the vise of knowledge it is then. Where's the vise of knowledge? The vise of knowledge is down here. Let's go in the rear end. So I'm going to put this here and I'm going to give it a little bit of a squeeze. It's very chewy. It's not really... Oh, that's quite promising. It may never go back together again. I'm wondering if a pair of pipe grips would be better for this. This is going to be absolutely destroyed by the time I finish with it, but that's okay. That's why I bought it. Ooh, right, tell you what, let's open the pipe grips up a little bit wider. Pipe grips are one of my favourite things for destroying cases. They're just great. They amplify the force of your already meaty hands to quite significant proportions. I don't want to chop the flex here, I want to leave it intact. Right, well, that's improved it greatly so far. Let's see if we can go one step further than that. That's done the trick. Oh, what do we have in here? We have an optical assembly up at the end there. That's quite interesting. It looks like it might actually have a fairly high power LED where we squeeze the other end and see if it also liberates with explosive force. It's not. I'm going to be careful how hard I squeeze here because the skin's cracking a bit at the moment. It's the winter blues. Oh, maybe I did squeeze a bit too hard. This isn't going well, is it? Some of you say I should leave this bit in. Normally I try and if it's like causing problems, I'll just sort of like remove it. So I'm going to leave it in. Oh, there we go. Oh, there we go. So it's a module inside here. And it looks as though it's it looks as though no, they can't have slid it in. It must just be. So what's holding it in? Hold on. I think this calls for a pair of snips. It's the very destructive video, this one. Let's put the other things out of the way because I think we've caused almost enough damage. Spooky. That's what electrical snips are for. They're for breaking things like this. They're so destructive. It's not so much Nipex as Ripex. Oh, this is looking quite promising. Am I going to get in here? Am I going to get anywhere? Am I going to impale myself horribly? It's not coming out yet. It's glued in some way. It's finding where that little bit of glue is that's going to liberate the mysteries within. Oh, there's the glue. And there's the module. It's not coming out the back. It's not coming out the back. I'm going to have to take it out the front, which means the lead. Oh, the lead is kind of trapped. Right, hold on. I'm just going to cut the rest of the plastic away. I can always glue it back together afterwards, he lied. So that's quite interesting. It's got a nice little projector module. That is quite neat. Let us open it. I shall dump all this plastic out the way since it's no longer needed, since nothing is going to go back together again. It can always be rehoused. So I did actually, I ran this from the bench power supply and it showed that it was only drawing about, well, dissipating about half a watt. Should I be? I'm not sure I should be taking that out. Let's take this out instead. Oh no. Right, one moment. Screwdrivers. I was saying something there and I've just forgotten what I was saying. Not to worry, that often happens. Oh yes, I tested it. With the 3-volt supply, it only draws about half a watt. Oh, this looks like it can actually slide backwards and forwards maybe for focus. Maybe? Not sure. Maybe I'm talking crap. I sometimes do talk crap. Ooh. Actually, I talk crap quite a lot. Ooh, it's threaded. Does it actually screw it out? Ooh, there's something trying to creep into shot here. That's out the way. Let's pull this off the end then. So what we got? Oh, that's a 1-watt LED with potentially a 3-watt LED with a really big heatsink in the back. That's quite nice. Oh, and it's got a collimating type. It's got the standard sort of collimating lens. Can we get more out of this? Is this going to do anything or is it glued in? Let's try gently prising at that with a screwdriver. Let's find a little flat blade screwdriver and just pop that lens out. It's refusing to pop out. It's popped out, as has a piece of plastic. There is the gobo, which does kind of suggest that this can possibly screw out. Is this molded? Not sure. It looks as though it's kind of... I'm not sure how that's little gobo bit is in. Let's bring in the grips and use unreasonable force again to gently squeeze and twist this. Is it glued? Is it solid? No, I think that's solid. That might be just poked in from the back. Let's poke it from the other side then. No, there is a layer in there. How is that held in? It doesn't look like this is screwed into any particular distance. It looks like that's solid. But there's almost that little bezel. Oh, there is a bezel. Look, there's a bezel. The bezel comes out and there is our gobo. So you could print out a fairly high resolution image on a laser printer or even an inkjet printer and print your own gobo. The actual diameter of the image is 3/8 of an inch, 1 centimetre diameter, 10 millimetres. It's interesting, right? Okay, next thing for taking to bits is, oh, you know what? I see what that threaded bit is. This goes into this threaded section here to get the focus, and then you can actually screw this backwards to screw it in, it's a reverse thread, or outwards to screw it out to get it to the focal position in that lens in the front here. That's interesting. So it does have potential. I'd like to actually see what it looks like with just the bare LED chip in it. And you know what? I will. Let's take the power supply to bits and check it, see if it looks a bit like a Jutai power supply. So I'm going to actually cut to the mustard. These are so much more pleasingly destructive that I'm going to use these to give that a little squeeze. Give it a little squeeze. Oh, it's quite tough. It's not really wanting squeezed at all. Oh, this feels so solid, which is good for a power supply, that I may have to pause momentarily to get this open. I think I'm going to have to pause for this. I don't think this is going to yield its little magic secrets without unreasonable force. I may have to go and use a hammer, which is a bit awkward because it's late at night and the neighbours won't be too pleased about that. But not to worry, this is occasionally what happens. Right, okay, one moment please. I would put it up to the faster speed, but it gets really loud very quickly. One moment please. Right, what do we have in here? Looks like a proper switchboard power supply. Let's whip that circuit board out. Let's find my long nose pliers. Grip that, and if it's anything like the Jutai ones, it will slide out. It did slide out. It's got the super separation, it's got the standoffs, it's got a proper class Y capacitor here. Switch mode chip, which is a, if you notice that steam, it's my breath actually. Can't read that chip. No, it's one of those, you know, when you use these little magnifiers, particularly when the chip is slightly grubby, the magnifier lights from a very specific angle, sometimes it's quite hard to read it. I shall read that. I shall take a note of what that chip is, and I'll put it in the description down below. So we've got the incoming supply here with these pins. This is the system that I quite like. It's a modular system that everything just slides in. How is that back actually held on? Where is it? It was presumably, yeah, a lip, I think, that pushes inside. That's why it wasn't coming out too easily and well glued and stuck, so pretty secure. So this module slides in, and the connections at the back make contact with the back end of these pins for the electrical connection, the mains connection. Then when this goes on, this connection just pushes on and goes into these connections. Very, very simple and modular. These are just super mass produced. So the incoming supply here goes through this resistor here. It's the color code is yellow, violet, gold. So that's 4.7, and it's actually a divider. It's 4.7 ohms. It then goes to the bridge rectifier here, diagonally mounted bridge rectifier, which is interesting, which then goes to this smoothing capacitor, which I didn't check if it was discharged. It is now. Then there's an inductor, and then over to another smoothing capacitor. So that's a bit of filtration. I'm not sure what's underneath that blob. Is there anything under that blob? I think that's maybe just to keep everything in position. The switchboard chip has some classic bits to it. It looks like it's got the usual, well, I shall go and look this chip up. That's the best bet. Okay, let's investigate this. We're not getting a lovely glossy picture this time. The Chromebook has just suddenly decided, no, I'm not going to print glossy paper anymore. It's the printer settings have changed, not quite worked that out. It's quite odd. Can still do it in the PC, which is fine. Let's take a look at the output. Look at this anti-tracking slot here with the high voltage, the spark gap here. That's quite good. It means that if there's too much strain between the output of the output winding, the secondary winding, and the primary winding, then a spark will jump across here. It just protects the windings and the components. So that is quite a wide gap. How is that? Wide is that gap? Where is it? It's quite wide. It's about 6 millimeter, quarter of an inch-ish. That's quite big. We have the incoming supply goes to the rectifier. This chip was very hard to read the number on. It was a mottled top, and it says LP3773D. I think this is I started typing the number and it's finished the rest of it. It seems to fit the bill. So let's take a look at the output first. So we've got the output has the secondary windings, which are here. So that's the secondary winding, which one leg is going straight to the output. There's a diode, a single rectifier diode, which this goes through the rectifier like that. There's a capacitor and resistor across that, a little sort of suppression network, almost like a snubber network across it for the switching, the diodes switching. What's the best way to describe that? The switching. Yeah, you sometimes get noise from diodes when they switch. We've got the capacitor under here, just this sort of current pulse as it turns on. We've got the negative here, we've got the positive here. The diode is going to the positive. We've got a resistor across it. It's pretty much textbook to this. The only thing that varies from the official schematic is it's got that little bit of extra filtering across this diode. It's got that little capacitor and a resistor just to suppress any noise. That's very good. The other section of the circuitry is quite complex. It's a fairly standard switch mode. We've got the incoming supply going through the bridge rectifier. We've got the negative, that's positive. That is going through a little inductor. That is negative, that's positive. We've got, here are the transformer pins. So we've got one connected to positive here, so that's positive to that pin, which equates to this here, and it's going through to the chip, which equates, it's actually pretty much connected to there by the look of it. That makes sense. And across that it's got a snubber network to protect the chip from the transient when it turns off. When the chip turns off, you get a slight spike across this winding here. So it's got this snubber network here, which consists, it's actually, they've increased it, they've boosted it up again. They've got a capacitor and resistor in parallel, that's that bit there. And then they've got a resistor in series of the diodes. So they've added an extra resistor in here, which is interesting. This is all good design. Then we get the classic bootstrap circuit where this capacitor here is here. There's the charge resistors. Give me a second. That's positive then. And that's negative, that is correct. So this should actually be connected. Hold on, I'm just going to check this on the meter. I'm just making sure that I get things right here. If you don't like this bit, you can skip over it. I'm fine with that. I know some people don't like it when I start probing. I just kind of get an interest in seeing. So this is the negative, and I'm looking for, it's on continuity. I'm looking for a connection over to here. That is, so yeah, that is the negative connected across the negative capacitors, which equates to that connection down here. Okay. Good enough. So what's actually happening here is that when you turn it on, there's going to be a very slight delay. This resistor here, which is actually these two here, will trickle current through. That's 1, 5 and 5 zeros. That's 1.5 megohm, 3 megohm total. Will trickle current through from the positive rail up here and start charging this capacitor. When it's charged up to threshold, it'll power the chip and it'll start running. Once the chip starts running, it then provides itself current through this diode here, which is connected in series with the resistor again, 3 ohm resistor. This is all really well designed. So it appears to be coming out like that, going across like that, and then that then is charging the capacitor up to the positive. And that is the other winding there. So that's connected to negative. That is tallying in. Yep, so that is the sort of bootstrap winding there, which is shown here, and is pumping that capacitor up to power the circuitry. That's the bit that if something goes wrong, like this diode fails, or you get a dry joint in the connection, or this capacitor fails, it'll be the bit that pulses it on and off. Then we've got the feedback current sense, where they've got a 4.3 ohm resistor and a 3.9 ohm resistor in parallel to fine tune the value. And then we've got a couple of resistors here for feedback, and that's these two. So they're coming from the feedback winding and providing a signal into the chip. That all makes sense. That is complete. That is a very good implementation. It's actually quite well made. That's nice. That makes a refreshing change. That just leaves one thing. I kind of want to put this together. and together again and see if I can resurrect it, but just actually not projecting the gobo, the little image, but actually just projecting a image of the LED. I'm not sure what that would look like. I kind of want to see what it looks like. So let's put the lens back in here, the collimating optic. And let's put, let me see, what can I do here? I think we can screw this bit back together. So we'll put this in here with the lens. The little lens goes up here. It's a bit fumbly. And we'll put that together. I think I should be able to just screw the other part in, so I shall put some screws in this. That seems logical enough. And then we'll try and put everything else together. Excellente. So it does have scope for modification, but it is a bit destructive going into it. So this bit goes down in here. This is the optical assembly, so I shall put this down like that. That works. No gobo, and it's going to screw in. It's not going to screw in there because I've screwed up. It's designed to stop it coming out too far. Okay, that's all right. Have I even used the right screws? Probably not. Do I care? Not really. Let's put this in here. The lead just folds underneath the LED, which is a bit Shanghai. Is this going to line up in a sensible manner? I don't think so. Then I shall do it in a non-sensible manner. Is there a little index mark here? Let's just try screwing the screws in and see if they go into anything. No, they didn't. Nice. Let's pop those screws out then. Again, you could just skip over this bit if you don't like it. If you like it, then just keep watching. There are some channels, a channel I've been watching recently, I'm just loving it, is South Main Auto. With Eric O, the mechanic, he's just really super skilled and really just relaxed. It makes me realise what it's like watching my channel, just watching him at work, because he's just basically saying exactly what's in his mind. It just makes it quite enjoyable. Oh, there's the little trough. There's a little trough at the back for the wires. Let's put that round there. The soldering of the wires onto the front is a bit crappy, but I think that's largely because of the heat dissipation of the aluminium heatsink, because it is nice to see it as a proper aluminium heatsink here. So let's try this again, shall we? Let's put this down here. That LED just keeps moving all the time. That is a bit footery. Not to worry, this happens. Half the fun of taking things to bits is actually trying to get them back together again. This looks promising. This looks very promising. Let's see if that actually goes in. Yes, it is. We're sorted. Now I just have to eke this open a little bit again, just so I can get this lens assembly in, and then we'll turn it on and we'll see if we can get an image of the lens. It's going to squeeze through like that. Am I going to use unreasonable force? Yeah, it's going to have to take it all out. Not to worry. What about now? Oh, it's come out anyway. It doesn't really matter. There we are. Yeah, Eric O of South Main Auto makes me realise just how good the diagnostic systems for cars are. They're really impressive. Right, what I'm going to do here, am I going to just hotwire this into the power supply, or am I going to try and put this circuit board back in here, ram it into electrical connections and just jam stuff together in a haphazard and dangerous manner? Let's go for the dangerous manner then. Ugh. And then that goes onto there. Will it still work? Will it go bang? Has it lit? It's lit. Oh, it's so much more light comes out when it's right. Okay, let's see if we can focus this. Let's turn the light off. Let's take the exposure off. Turn the light off. Let's turn that light off so we get maximum and see what I can focus here, what sort of focus I can pull on it. Can I focus directly onto the chip? Oh, pretty close. I don't think it goes right up there, but that's not bad. It's really swamping out. Hold on, I'm just going to try and, this is a terrible idea. It's not going to work. Oh, it kind of didn't work. So that's at one end of the focal distance, and this is at the other end of the focal distance. So it doesn't really make much of a difference. But if your little gobo was in there, you could fine tune the focus onto that. And that is Poundland's Halloween light. So actually, it was quite good to take to bits. It's quite nicely made inside, but a bit of a one-way trip. If you take it apart, it really is well glued together.